네, 말씀 잘 들었습니다. 자, 다음 연사도 역시 이 인공지능과 관련된 분입니다. 기업 측면에서 인공지능 개발에 힘을 쓰고 계시는 분을 한번 초청해 보겠습니다. 2011년에 TV 퀴즈쇼 제퍼디라는 쇼 아시죠? 인간 퀴즈왕들을 다 물리치면서 큰 화제를 일으켰던 그 우승자가 있습니다. 사람이 아니고 슈퍼컴퓨터 왓슨이었습니다. 이 IBM 소프트그룹 솔루션 부문에서 이 왓슨이라는 슈퍼컴퓨터를 만들어서 제퍼디라는 퀴즈 프로그램에서 아주 성공적인 데뷔를 했었는데, 바로 이 왓슨 프로젝트를 담당했던 최고 기술 책임자 롭 하이 CTO를 이 자리에 모셨습니다. 박수로 환영해 주십시오. Welcome. Thanks all yours.
Very good. Let me take you back a few years to 1947, when Jonathan Van Neumann began work on what has become the blueprint for all modern computer architecture. Now, what's interesting about Von Neumann is that he was a mathematician, and he built the modern computer for mathematicians. The computer that we know today, the derivative of the von Neumann architecture, has been incredibly useful to us in society. Without computers, our banking systems wouldn't work. Our ability to get reservations on airplanes wouldn't work. Our ability to communicate with each other wouldn't work. Our ability to broadcast this forum wouldn't work. And so computers have been incredibly useful for us. But computers have largely been used for the purposes of executing mathematical models that we have formulated to represent realities that we want to reason about and execute within the computing system. These mathematical models are important to helping us understand the realities that we have to deal with. But they're just that. They're mathematical models. They're approximations of reality. They're approximations that allow us to simulate realities for the purposes of reasoning about them. But the problem with this is that only about 20% of all the data in the world today is amenable to being processed with a mathematical model, with mathematical precision. The other 80% of the data in the world, our text, our literature, our audio, our video, computers really don't understand. They don't understand what the real meaning is behind that information and how to process it. And yet that information is growing at an enormous rate. Today, 90% of all the data that we have available to us was created in the last 2 years. Within the last few years, all the information that we produced is more than all the information that had been created previously in the entire history of mankind. So today's society is creating an enormous amount of information, most of which computers don't truly understand. They can't fully comprehend the meaning and intent of what we're expressing. So we set out on a project that we now refer to as Watson, as a Watson program that we created for the purposes of playing the game of Jeopardy. But the real purpose of that was to be able to discover how to understand language and the cognitive process. Now, back at the beginning of the last century, Ludwig Wittgenstein made a comment that the limits of my language are the limits of my mind. That all that I know is what I know from the words that I have. And essentially what he was saying is that our cognitive processes as humans is fundamentally based on an understanding of language. It's the invention of language that allows us to express our ideas and concepts. It's the language of our mind that allows us to reason about the logical progression of different ideas and to evaluate those ideas in a way that we can manipulate and make use of. And so by focusing on language, what we essentially are doing is beginning the task of simulating human cognition so that computers can understand what we mean and our ideas and to be able to answer questions that we might form in that language. and to be able to read the hundreds of millions of pages of literature that have been produced from which information and answers could be formed. And so we introduced this notion of what we now refer to as cognitive systems. A cognitive system is one where the machine learns how to understand and to formulate its behavior. It's different than what we've done for the last 67 years of modern computing, where everything today has been formed based on programs, software that captures the symbolic logic of mathematics. Going forward, as we build these cognitive systems, what we're finding is that what matters is the probabilistic nature of the human condition. The probability that when somebody says something in a certain way, that they meant it to be interpreted in a certain way. The probability that the context in which that is said is contributing to an understanding of the expression. And so these systems learn the extent to which those characteristics and those contexts are applicable to helping interpret the meaning of both the questions as well as the answers, the literature that we might read from which we can find information that might answer the question that we're looking at. So we've built these systems, they learn their behavior, they're informed by the language of our human experience, that is the material, the literature, the articles, the reports that we produce that we use as humans to communicate with. The computing system in Watson is ingesting and reading just like another human being might do. And so it learns through the process of assimilating knowledge and learns through trial and error to determine which of all its interpretations is most likely to be valuable and appropriate for interpreting what anybody may be asking or answering. Right? These systems evolve their behavior. Right? They build hypotheses and test those hypotheses against a set of conditions that it can observe. So the question is, what have we been doing with this? Once we have created the Watson system and we're able to use it for playing the game of Jeopardy, we didn't want to stop at playing a game. This was not about playing games. This was about truly understanding human language and being able to tap into the other 80% of the information out there that is growing and growing rapidly to make use of. So we've done work with healthcare, and particularly working with institutions like Memorial Sloan Kettering and MD Anderson and WellPoint to understand the human language expressions of not only the patient, but also the literature that might be appropriate for helping doctors make treatment decisions, and particularly in the area of oncology. And so what Watson does is it goes out and it reads the medical record for a patient. And if you're ever familiar with a medical record, what you will normally see is lots and lots of paragraphs of written information where the clinicians, the doctors, the nurses, and other clinical technicians have written down what they have observed about this patient, or what they have recommended or prescribed for this patient, or their interpretation of the patient's diagnosis. And all of that material is written. And so with Watson, we're able to go in and read that material and summarize it. And so if you're a doctor and you only have 5 minutes to read up about this patient before you go in and meet with them, there's a good chance that if on your own you had to read all that material, you might actually miss a lot of very important information. Whereas Watson's able to read all of that and very quickly come up with a summary that's relevant for the doctor in their diagnosis and in their consultation with the client. We also do population similarity analytics, where we examine what's similar between this patient and the million other patients that a place like MD Anderson has seen. So if we can find the microsegmentation, the 10 other patients that are just like you, not just based on your age and gender and race, but rather based on the 5,000, the 10,000, 15,000 other variables that constitute who you are, your family history, your genetics, your environmental exposures, your history of other diseases and pharmacology that's been used to treat you. When we find the 10 other patients that are just like you, we're able to draw some conclusions about what kinds of therapies are going to be effective for you based on the responses that we saw from the other 10 patients that are just like you. And not only just what the response is going to be, but in fact what the side effects are going to be as well. Because a lot of times when a doctor is presented with a therapy option, if the doctor is not familiar with that therapy, they may not prescribe it. Even if it's a better and more effective therapy, if they don't understand the side effects that could occur, and they don't know how to respond to those side effects in an appropriate manner, sometimes those adverse events can be more detrimental to the disease itself. And so if a doctor is not comfortable with how to manage the therapy, they often will bypass it, even if it turns out to be a more effective therapy. They will resort back to those things that they're comfortable with, that they're familiar with, that they have experience with, and have some sense of how to respond to. So we do the population similarity analytics to try to identify the microsegmentation of the population of patients that are just like you. Then we go on and read the standard of care practices, which are often written. They're written for the purposes of exchanging knowledge with other doctors, and so therefore they're written in a human language form. We read that. We understand what those guidelines are, what the pathways are for treatment. And then we overlay that with clinical expertise. And this is where we have gone in and worked with doctors, some of the best doctors, and captured from them knowledge about the choices that they make and the decision criteria they consider when they eventually make a decision about a therapy. And by capturing that knowledge, we can overlay that on the standard of care practices and bring that clinical expertise to everybody else who may not have the opportunity to see 1,000 patients a year, right? Or may not have had years and years of experience that has informed their own decision-making processes. So in that sense, we're democratizing clinical care. We're taking the expertise of experts, of clinical experts, and we're bringing that out to all the other doctors in the regional and community centers and rural areas where not only do they not have access to all the facilities that allows them to deliver care, but in fact, in many cases, they don't even have the same level of education and experience that those in the clinical expertise areas, centers of expertise, have been able to experience. And then finally, we go in and we read all the clinical literature, the hundreds of thousands of reports and papers and articles and hospital reports and so forth that have been useful in capturing knowledge about how different patients respond to different therapies and the side effects that they may create and all the drug interactions that may be relevant to consider within a therapy. And by bringing all that together and giving that to the doctor, we've essentially augmented their ability to make choices about therapies that could be potentially more effective and reduce not only the incidence of secondary issues, but also reduce the cost of managing care for these patients. The other thing that we've been working on is in the consumer support area, recognizing that consumers, people, have questions about the products and services they may be interested in buying or using or getting the support for. And a lot of times the questions they want to ask can only today be answered by one of three different means. One is that they call a person, an expert, a service representative, and try to ask them questions about the products, and that turns out to be only useful about 50% of the time. Half the time, the calls that consumers make to the institutions where they might be interested in buying a product go unresolved, unsatisfied. The alternative is they go to that organization's website and read all the marketing literature and product literature, which could be very time-consuming, and oftentimes, again, leads to not resolving the questions you have. Or the third is that you go to a social site, a website, a forum, a blog, someplace where other people have offered their opinions, but often they're just that. They're just opinions. And sometimes those opinions are inaccurate, and sometimes those opinions are misleading, and sometimes those opinions are somewhat negative. And because those are the choices that people have available to them today, there's an enormous opportunity to lose the relationship with your clients. And so we felt like there was an opportunity for us to bring in something like Watson to answer questions for consumers that gives them the information they are looking for, and not just about the products that they're buying, but even in the context in which they're buying those products. So imagine if you are out there looking for a mortgage and you want to buy a mortgage from a bank. Well, the chances are it's not just the mortgage that you're interested in. In fact, it probably isn't that you just woke up one morning and said, hey, I want to buy a mortgage. The reality is you're buying that mortgage because you're probably buying a house. Or if it's a loan, it's because you're buying a car. Or if it's a microloan, it's because you're trying to fund your business. You have other questions you want to ask. If you're buying a house, you want to know what the rental market is like versus the resale market is like in your neighborhood. You want to know what the schools are like. You want to know what the local facilities are like for shopping and for entertainment. So you have all these other questions, and if as an institution you can answer those questions in addition to answering questions about your product, now you begin to enable a much tighter relationship with your client. You can engage your client and you can maintain the experience that your client's going to have, and therefore encourage a stronger, more loyal relationship over time. They're more likely to buy products from you. And so we're using Watson to go out and read all the marketing and product and ancillary information that may surface in different blog posts or forums or articles that are curated, are validated to have information that is useful and meaningful and correct. And then we read that in. Watson reads that in, it understands it, and uses that as a source for answering questions to consumers that may be interested in buying products from your organization. And the next thing is that a few weeks ago in Austin, Texas, we demonstrated this idea of cognitive cooking. And in here, what we did is Watson ingested about 35,000 recipes. And from that, it learned what different cuisines are. You know, what is a Korean dish versus what is a Southwestern dish? It learned what different types of dishes there are. What is a quiche, right? What is a pie? What is a salad? What is a sandwich? And then we further informed it with the science of taste chemistry. What are the primary chemicals that different foods have that give them taste? And what is the combination of chemicals that make something taste good together? And from that, you can go to Watson and the cognitive cooking system, and you can tell it, I want to have a Korean quiche that has chicken as its primary ingredient. And Watson will go out and evaluate what turns out to be 6 quintillion permutations of ingredients, finding those that pair well together, finding those that are relevant to helping build a Korean dish and a quiche, right? And coming back to the chef with a set of recommended recipes that have been created from scratch, have never been created before. No other chef has produced these recipes. Entirely novel recipes. Combining ingredients in ways that chefs today may not be prepared or educated to expect. And yet, because it knows enough about the chemistry of taste, is able to produce things that are actually quite delightful. There was a case just recently, I was telling somebody else this morning, where the cognitive cooking demonstration came back and suggested pairing cherries with mushrooms. Nobody's heard of this. Nobody's combined cherries and mushrooms. That doesn't even necessarily sound good. But it turns out that when you combine these two ingredients, it comes out with this beautiful taste. And so we're bringing to the chefs a level of creativity that by themselves would not have considered, because we as humans tend to get focused on the few things that we're taught and learned to expect, and we focus on just that and nothing else. Now, at the beginning of this year, we announced the formation of the Watson Group, and part of the reason for doing that was because we recognized that this thing called cognitive computing, this thing that we've captured within Watson, is going to be transformative and absolutely essential to the future of our world, not just within the computing space, but within all the things that we do in society and in business. And with that, we created a Watson ecosystem where we invited vendors to come in and offer to create applications that leverage the cognitive platform that we've produced. And in that, leverage the cognitive services that enable applications to go out and do things that we couldn't imagine before, right? And bring the value and benefit of cognitive computing to people in walks of life that we would not normally have the opportunity to access. And with that, we introduced a content marketplace and a skills cloud so that we can develop and educate people on how to create cognitive solutions. So far, we've had about 2,500, over 2,500 vendors come and apply to create applications on top of this platform, and that's growing rapidly. That's just since January. We also created a $100 million equity fund to fund startup companies who want to create a new business out of this cognitive space. And so we're off to a tremendous start here. We have services coming online on the platform, and we have people that are rapidly creating applications to bring to market. So just to kind of summarize here, I think that in 20 years from now, when we look back at today and where we are in the apex of our computing industry, we're going to realize that we were at a turning point, and that the future of computing is going to be dominated by this idea of cognitive computing, the ability for the human to be simulated to a degree within the computing system for the purposes of advancing our own creativity. And ultimately, that's what this is about. It's about amplifying our creativity. It's about making our creativity stronger in much the same way that the industrial age allowed us to amplify our human physical strength, and the beginning days of computing allowed us to amplify our mathematical strength. In the cognitive computing space, we will use computers to amplify our human creativity and give it strength and be a forcing function and force multiplier for our creativity. And these systems will essentially be known because they learn the behavior and they express in human terms the things that are meaningful for the computer to work with, right? And they evolve and they express a certain level of expertise. That's what is going to happen in our world. That's what we're seeing happening today as we transition into this new era of cognitive computing. Thank you.